Okay, you guys want me to do a cool intro? Hello, my baby. Hello, my darling. Hello, my yeah.
I did not want to see that.
I did not do anything bouncy at all. Yeah. Yeah, I probably will. Okay. Okay. What we are about to do, folks, we are about to answer. There's someone at the door. Oh, Naomi's at the door. We are about to do questions 19 through 36 on what I called the advanced derivatives rules worksheet. Okay? Are we okay? All right, good. So let's do 19 now. This is what I call a mixed bag, okay, or mixed nuts, which means this. On the front of the worksheet, I did 6 product, then 6 quotient, then 6 chain. And so you didn't really have to figure out which rule to use. On the back, there's 6 product, 6 quotient, and 6 chain, but I mixed them up. Now, the quotient rule ones are pretty easy to recognize. But sometimes the chain rule can look a little bit like the product rule, so just be careful. Yes?
Are we ever going to use like 2 rules on one problem?
Yes. But not today and not on this test.
Thank God.
Okay? But yes, there is the possibility to have something to where you have a product rule nested inside of the quotient rule, and then the chain rule also nested in there. Yes? It is, yeah. Hey guys, listen, I want to note something that Hugo just said. Hugo said sometimes it is easy to recognize the chain rule because it has parentheses around the inside function. Though that is not true for the e functions, like e to the 4x squared, obviously, now you could put parentheses, but you don't have to. But it's still a lot easier to see it in an e to the x. But when you have sine, if it's not sine of x, then it's going to have parentheses. You know, sine of natural log of x. It's sort of, you see the parentheses there, you kind of notice that it's the chain rule. So let's look at question number 19. 19 says that y is equal to, you're saying product rule, 5x to the 4th, natural log of x, 5x to the 4th, natural log of x. Sure enough, we got a multiplication here. This is a product rule. So, dy dx is going to be derivative of the first, 20x to the, 20x to the 3rd, times the second, natural log of x, plus the first, not change, 5x to the 4th, times the derivative of the natural log of x, which is 1 over x. Yeah, what can this turn into?
5x to the 4th.
Yeah, 5x to the 4th over x, which becomes 5x to the 3rd. Yep. So we could just simply write here 5x to the 3rd. If you're watching this and you didn't understand what I just did, you need to go back 3, 4, 5, 6 times, however long it takes, to understand that all I did was multiply and then simplify. Okay? All right. All right, question number 20.
I can
All right.
identify which one it is.
All right. You can't identify number 20? You can. Yeah, I figured you could. All right, y is equal to, we have secant of x over x. So what rule can we apply here? Quotient rule. So y prime is going to be, what's the derivative of the top here? Tan secant, right? Tangent of x times secant of x times what? Times the bottom. And I like to put, when I'm multiplying by a polynomial trig, I usually put the x out front.
Can we put it in the back?
Yeah, you can put it in the back if you want to. But let me tell you something. It looks a little freaky. It looks a little freaky to see secant of x times x. This looks a little freaky for some people. They want to do x times x, and this is not secant of x squared. No, yeah, okay, so it's 5x to the 4th times 1 over x. Yep, and so then we wind up dividing out an x. So I'm going to put this x up front because for me, I really prefer having my polynomial in front of my trig function. All right, minus the top, secant of x. So we've got derivative of the top times the bottom minus the top times, what's the derivative of x?
0. It's not.
Ah.
Wait, hold on.
You're thinking of the derivative of a constant.
No, it's 1. Isn't it?
It's 1. Guys, what is the derivative of x? It's 1. So this is secant of x times 1. So we don't have to put anything. Yep. All over the bottom squared, which is x squared. There we go.
Oh my God.
Okay? There's your derivative. And you can leave it as is. I mean, a person could factor out a secant, right? Okay. But a person won't. A person named Adrian won't. All right. 21. Now your name is on video. Yeah. All right, 21. G of x equals e to the 6x, right? Okay. So g prime of x is equal to, what rule are we going to use here? Chain rule. What's the derivative of the inside function? 6 times e to the, good to go. Moving on. 22. Am I going too fast? We're good? Okay, good. We'll be done soon enough. All right, 22. Yeah, this is it. A of t.
No.
Let's look at it. Yeah, what'd you say, Tiffany? That's a product rule. This is 3t times e to the t. There we go. 3t times e to the t. So this is we had a product of 3t times e to the t. So a prime of t is equal to derivative of this, 3 times that, e to the t, plus this, 3t. Derivative of e to the t is e to the t, and we're done.
Wow.
Does anybody feel like they're going faster? Does anybody feel like they're... I mean, y'all are done back there, right? They went pretty... See? They go fast after a while. I'm leaving these, and I'm erasing these over here. Just erasing 19 and 20. Is it? 23?
Yes,
All right, 23. Sure enough, product rule.
No.
We got f of x is the natural log of x times secant of x. And now f prime, derivative of this, right? 1 over x times that, secant of x, plus this, natural log of x, times, what's the derivative of secant? Tan secant, right? Tangent of x times secant of x. This right here, you can make that secant of x over x.
I was about to ask you that.
Yeah, you can make that one secant of x over x. So it would wind up being secant of x over x plus natural log of x times tangent of x times secant of x. Yes?
Could the x's cancel?
Okay, these x's in here, is that what you're asking about?
Secant over x.
No. Okay, let's explain that. Do you remember the question you asked, what does the word transcendental mean, right? And I said transcendental means that the rules for these functions transcend algebraic rules. That x, secant is doing something funky and complicated to x. This is not secant times x. This isn't the same thing as like 5x over x. So no, we cannot cancel. Okay? Secant of x is something complicated and transcendental. Okay? So we leave it as secant of x over x.
What's the limit of secant of x over x?
That's a good question. At infinity or at a particular value? At 0, secant of 0 is 1 over cosine, so 1 over 1. So there's a vertical asymptote. Yeah, because it would be 1 over 0. It's not the same thing as sine of, right. Now, cosecant of x over x is 1. I don't know if you remember your trig functions, but you know how sine does this? Sine does this, cosecant does this. If you've never graphed sine and cosecant at the same time, this is what it does. So sine of x over x and cosecant of x over x is going to have a similar look to it. Okay? Yeah. Okay. 24. So let's do question number 24. Y equals. Okay, this is actually our first negative function. I haven't messed with negatives up to this point, but now we're going to mess with negatives. So we got it's not that big of a deal. It's just negative 1 times. So negative e to the power of cosecant of x. What function are we looking at here? What's that? This is a chain rule, right? So dy dx is going to be derivative of the inside, which is negative cotangent cosecant times what?
Negative.
Times negative e, right? All right, now, so since we're about to multiply by negative e, we got a negative cotangent cosecant times negative e. We got a negative times a negative. It's going to make a positive. So it's going to wind up being a positive term. Okay, and it's going to have an e to the power of cosecant of x. There we go.
Oh, we're almost done.
We're close, right?
Wait, so what happened to the negative?
It cancels out.
Say again?
What happened to the negative?
Okay, would you agree that the derivative of cosecant is a negative term? And would you agree that the derivative of negative e, isn't the derivative of negative e to the x negative e to the x? So we're ultimately going to be multiplying two negatives by each other, making this a positive term. I don't think they spend enough time in lower levels, like y'all don't get enough exposure to this idea of a negative times a negative. It happens so frequently in math. Can you guys chill out? It happens so frequently in math. Well, just chill out on that particular. It happens so frequently in math, but a lot of times it's not emphasized. It is emphasized greatly in calculus. Many of the, I would say probably 1 out of every 4 or 5 problems that I have done from the AP exam have had some element of the idea of, oh, since this comes out to be a negative times a negative, it will be positive. Or since this is squared, it will always be positive. Does that make sense? Yeah. So always be on the lookout for negative terms multiplied by negative terms. Whoops, I shouldn't have done that. Cotangent cosecant of x times e to the cosecant of x. Let's erase 21 and 22 over here. All right, let's try 25. Yeah, we're real close here, aren't we? 25. What is it? G of x, sine of x over natural log of x? G of x equals sine of x over natural log of x. Which rule are we going to use? Quotient rule, because we got a quotient. Derivative of the top always starts with derivative of the top is cosine of x times the bottom minus the top sine of x times derivative of the bottom 1 over x all over the bottom squared. So as also say natural log squared of x, or you could write it as the natural log of x squared. Oh, have you? Yeah, good. Yes. Here. Oh, here. No. Okay, you could if there was also 1 over here. Here's the rule. I don't think they describe it like this typically in algebra. What they teach you to do in algebra is to factor something out and then cancel it. But another way to understand it is if in a fraction, top and bottom, there is something in every single term, you can knock 1 out of every single term. There would need to be a natural log in this term here. Okay, if there was a times natural log of x here, I could then factor out a natural log, then cancel it. But see, what you're trying to do is you got to remember the house of math. You're trying to vandalize the house of math. Okay? The house of math, you can't, in order to divide a difference here, okay? See, multiplication has to distribute over addition and subtraction in order for you to then divide out. I don't know if that makes sense. Here, watch this. Here's what I'm going to do. Natural log of x squared, right? I'm going to change this. Ready? This is the same thing as cosine of x times natural log of x over the natural log of x squared minus sine of x times 1 over x, which could be sine of x over x, over the natural log of x squared. Do you know why this is correct? Common denominator. This is not an issue of multiplication or division. This is subtraction. Remember, subtraction in fractions is difficult. Does anyone remember this? Did your teacher in 3rd or 4th grade, when you learned about fractions, they said, I know that addition and subtraction is easier than multiplication and division sometimes, but in fractions it's easier to multiply and divide and harder to add and subtract. No. They didn't say that to you? They should have said that to you. Does anybody agree with me? Does anyone agree with me on that?
The only hard thing is finding a common denominator.
Right. Do you need a common denominator in multiplication and division? No. Because you need a common denominator in addition and subtraction, to me, that makes addition and subtraction of fractions more difficult. So look, what did I do with this? Did I subtract, or did I combine the denominators together, or did I break them apart? Look what I did.
You broke the numerator apart with the common.
Yes. See, when you were in elementary school, this is what you did. Your teacher said, find 2/3 minus 1/2. Am I right? Or let's make it even, minus 1/5, right? Your teacher said this, right? And then you had to find a common denominator. I think it's 15, Miss Smith. So then you had to do, 5 times 3 is 15. 5 times 2 is 10, minus, over here we have to multiply by 3. So 3 times 5 is 15, 3 times 1 is 3, and I got a common denominator, yay! And then 10 minus 3 is 7. Do you remember doing something like this? Okay. Did your elementary school teacher then, the next day or 2 days later, turn around and say, now we're going to learn how to take this apart? No. That's why you aren't that good at taking subtraction of fractions apart. You know how to do this, but do you know how to do this? If we have 4/7, could you then turn that into 10 minus 6/7? Isn't 10 minus 6 4? And then turn that into 10/7 minus 6/7. Right? Is that okay? Yeah, that's all I did here, was I took the subtraction apart. Now that the subtraction is taken apart, okay, you ready? You ready? Can I cancel a natural log? You betcha I can. Yep. Can I cancel a natural log over here? No, because there is no natural log. That's why I'm telling you up here, no, you cannot cancel. But so many students want to do just that. When students see x squared minus 5 over x, I know they want to do it. I know they want to do it, but you can't. They want to cancel one of the x's. There's no x over here. You can't cancel anything here. X squared minus 5 over x, that is as far as you can go. You can't do anything about that. Okay? Does that make sense? All right. You ask such good questions. You do. Okay. Let's leave this. Okay, let's go to 26. Question 26. We have natural log of cosine of t. A of t is the natural log of cosine of t. I love this one. This is a really good one. A prime. What rule am I going to use here? Chain rule. Okay. Derivative of the inside. Negative sign. Times the derivative of the outside. 1 over cosine. And what can I now do with that? Negative sine of t over cosine of t. Which is? Come on, guys. It's negative tangent. Yay! All right. Oh, sorry, it's t. Sorry, thank you. Negative tangent of t. There we go. Thank you. Isn't that cool isn't it cool that the derivative of a natural log is a trig function? I think that's pretty cool.
It's awesome.
Yeah. Negative trig, yeah. All right, let's go over here. Let's do 27. All right, 27. We got v of t is 2t sine of t. 2t sine of t. Product rule, v prime of t. Derivative of the first 2 times the second sine of t plus the first times the derivative of the second cosine of t. Done. 28. Derivative of the first times the second plus the first times the derivative of the second. 28. We got f of x. We got cotangent of 3x. This is a good one. They like ones that look like this on the AP exam. They like just doing the 2x or the 4x or the 5x or something. All right, derivative of the inside is a chain rule. Derivative of the inside, 3. Derivative of cotangent is cosecant, negative cosecant squared. Right? And of 3x. So I put the negative on the front. I put 3x in the inside, and it's cosecant squared.
Do we have to put it in the front? Yes. No.
Okay. If you don't, it better look like this. And let me tell you why. Folks, let me tell you why. Because I can't tell you how many times in the last 6 years I have had a student give me this. And guess what?
It's wrong.
This is not 3 times negative cosecant squared. What is that? That's 3 minus cosecant squared.
Well, I put 3 times.
Right, yeah. I really do not recommend that. I recommend that if you are going to multiply by a negative term, I highly recommend parentheses. Even better, where does a negative sign belong in a term? At the front. A negative sign in a term, based on the way we communicate it in math, a negative sign belongs at the front. That's where it belongs. Just based on the way we communicate in math. It's not like, it's not like the world's going to fall apart or something, Okay, because the derivative of cotangent is negative cosecant squared, right? Remember, the derivative of any cofunction is the opposite sign, right? All right, so 29, we got here. We got g of x is, what does this look like to you? This is a product rule, cosine of x. So g prime of x is derivative of the first, 30x squared, times the second, cosine of x. Now, it would be plus the first, but then the derivative of cosine is negative sign, so it's going to become minus. See, this is why the sign belongs at the beginning of the term. It turns into addition, or it turns into subtraction. Sine of x. 30. All right, a of t. We've got a quotient here. Negative 3t to the 4th over natural log of t. So that's a g. A prime of t, derivative of the top is negative 12t to the 3rd times the bottom, natural log of t, minus the top. Yeah, it's going to become a plus because we're now going to put in negative 3t to the 4th, so it's going to be plus 3t to the 4th times the derivative of the bottom, 1 over t, we'll get back to this, over the bottom squared, that's an h. Natural log squared of t, or natural log of t in parentheses squared. So we do that or this. And now, what's this going to become? 3t cubed, because 3t to the 4th over t becomes 3t cubed. That 3t cubed. Just trying to make sure we get. Gab, you got about 4 minutes. So it's 30. Let's go. We only got 6 left. I think we can do it. 31. V of t is e to the negative t. I love this one. It really throws a lot of people off. This is a very, very simple problem that can be given to students to determine whether they know how to find the derivative of an exponential function and apply the chain rule. Yes, what do you got?
I have a negative e to the negative t.
That is correct. Yeah, because what's going on here, folks, is this is a chain rule. Some people don't think of it as a chain rule. They think it's just e to the negative t. But remember, this is not just t. It's negative t, so we need the chain rule. We need, what's the derivative of negative t? Negative 1. So negative 1 times the derivative of the outside is e with the inside unchanged, e to the negative t. Negative e to the negative t. That's a good one.
There can't ever be negative exponents? No.
Okay. What I mean is this. Okay. Yes, you're right. I agree with that. Okay. However, it's okay to have negative exponents when the exponent is the variable. What I mean is I don't want to see t to the negative 2 power. Do you see the difference? Okay. So I guess I should revise it. I don't want to see negative exponents on a polynomial. Does that make sense now? Yeah. Okay. All right. Or on a, I should say on a power function. All right, 32. Let's see, f of x is e to the x over cotangent of x. We've got a quotient here, so f prime of x is going to be e to the x times cotangent of x, through the top times the bottom, minus the top. Oh yeah, why is it going to be plus? Because the derivative of this is going to be negative, right? So it would be minus, but since we're going to multiply by a negative, so plus. What's the derivative of cotangent? Negative secant squared, or cosecant squared. But we already combined that negative with this negative over here, making it a plus. Over cotangent squared of x. 4 more. Abby, you got about a minute and a half. Oh, did I say Abby? I meant Gabby. Sorry. I have 2 Abbies in other classes. So I got Abby, Gabby, and another Gabby, I think. So, yeah. Yeah. When you have 150 students, you just, V of t. 7t squared over e to the t. 7t squared over e to the t. So v prime, derivative of the top, times the bottom, minus the top, times the derivative of the bottom, over the bottom squared. Right? 34. All right, curious. Does anybody agree with my prediction that if a person just did all 36 of these, that they would know these rules? Okay. Yeah. Yeah. Well, there's a quiz next Thursday, so. Okay, why? The practice one is on Tuesday. Practice quiz on Tuesday, real quiz on Thursday. This one's probably going to be 20. Yeah, because we got a lot of derivatives to cover. You got to know all the derivative rules. Okay, so e to the x cosecant of x, which rule? Product rule. Derivative of this times that plus this, the first one, times the derivative of the derivative of the second one is negative. I've got to change this to a minus. And it's cosecant, cotangent, or cotangent, cosecant. Either way is fine. Ta-da. Great thing about video is you can slow it down. You can pause, well, not slow it down, you can pause it. You can rewind. 35. Okay? There's no reason with this video on the internet and this worksheet, there's no reason any of my calculus students should not know solid all the derivative rules. All of them. H of x. All right, negative cosine over 8x. Okay, good. H prime is going to be, okay, sine of x, derivative of the top, times the bottom. 8. I'm going to put the 8x at the front, if you don't mind. All right, minus, the top. So it's going to be plus, because minus negative cosine is plus cosine times 8. The derivative of the bottom, I'm going to throw that up front there. I know I'm squeezing a lot of stuff in. Over 8x quantity squared, which is what? Yeah, that's the same thing as 64x squared. So 64x squared. Last one. This is the one you were were you asking about this one, or I asked you about this one? Okay, yeah. 36. Let's see. We got h of x is equal to, yes. All right. 4 sine of x to the 5th power, right? Okay, let me explain. Okay. What would be here? There would be an x here. So this is the same thing as 4x to the 5th, only with a sine x on the inside. See that? Okay. So when we do the derivative, h prime of x, what's our first step? Start with cosine, right? Because we want to do the derivative of the inside. So cosine of x times. Yeah, well, what would the outside be? It would be 4x to the 5th. So what's the derivative of 4x to the 5th? 20x to the 4th, but 20 sine of, sine of x to the 4th. Yep. So times 20 times sine of x to the fourth. Now let me show you how you can clean this up. Yeah, that's what we're going to do. We're going to put the 20 in the front. Okay. Then the cosine of x. Now, ready for this? What is sine of x times itself 4 times? Sine to the fourth of x. Yep. There we go. And we're done. Should I do a conclusion?
Do a sign.
Ta-da! What do you want me to do? Signing off?
Do like a sign off.
This is Mr. Ryan.